Today's question is, what was the largest earthquake of all time? We can't speak about the largest earthquake since the formation of the Earth 4.5 billion years ago, only the first earthquake ever recorded since instruments were developed. The first known earthquake detector was invented in 132 AD by the Chinese astronomer and mathematician Chang Heng. He called it an earthquake weather clock. Earthquake recording started more accurately after the development of the seismograph. Earthquakes that were not measured by instruments, such as big ones that occurred thousands of years ago, were described and investigated using the geologic record and subsequent interpretations. Earthquakes today are recorded by a vast seismographic network around the world. Back to the question, what was the largest earthquake of all time? The biggest earthquake ever recorded, of magnitude 9.5, happened in 1960 in Valdivia, Chile. A megathrust earthquake resulting from the release of mechanical stress between the subducting Nazca Plate and the South American Plate on the Peru-Chile Trench. The focus was relatively shallow at 33 kilometers. The second largest earthquake ever recorded had a magnitude 9.2 and happened in 1964 in Alaska, at another subduction zone where the Pacific Plate dives under the North American Plate. The other large earthquake in recent times was the infamous 2004 Indian Ocean earthquake in Sumatra, Indonesia, which triggered a devastating tsunami that claimed 250,000 lives, also occurring at a subduction zone with a magnitude of 9.2. The most powerful earthquake ever recorded, the 1960 earthquake in Valdivia, Chile, occurred on a fault that is almost 1,000 miles long, an extraordinarily large megaquake in its own right. The earthquake produced a 500-mile-long rupture zone extending from Talca, Chile to the Chile archipelago. The earthquake lasted for approximately 10 minutes. The largest was a sequence of strong earthquakes over a few days and was preceded by a powerful foreshock. 4 foreshocks greater than the magnitude of 7 had occurred. After the preceding foreshock, many people were frightened and left their buildings. That placed them outside when the main earthquake occurred during the afternoon of May 22, 1960. As a consequence of the large earthquake, tsunamis affected southern Chile, Hawaii, Japan, the Philippines, eastern New Zealand, southeast Australia, and the Aleutian Islands. Localized tsunamis severely hammered the Chilean coast, with waves up to 25 meters or 82 feet. Tsunamis generated by the earthquake traveled across the Pacific Ocean at a speed of over 200 miles per hour. Here's an image showing travel time of the tsunamis across the Pacific at 1-hour intervals. The main tsunami traveled across the Pacific Ocean and devastated Hilo, Hawaii, where waves as high as 10.7 meters or 35 feet occurred. It arrived 15 hours after the earthquake and killed 61 people. About 22 hours after the earthquake, a tsunami arrived in Japan and killed about 138 people. 24 hours after the earthquake, a tsunami arrived in the Philippines and killed 32 people. Damage occurred at other places such as Easter Island and Samoa. At the main port of Valdivia, the water level rose 4 meters or 13 feet before it began to recede. A wave of 8 meters or 26 feet struck the Chilean coast. Another wave measuring 10 meters or 33 feet was reported 10 minutes later. Changes in sea level were noticed all around the Pacific Ocean basin. Overall, between 1,000 and 6,000 were killed in the earthquake of 1960. The relatively low death toll in Chile is explained in part by the low population density in the region and by building practices that took into account the area's high geological activity. Ground motion from this earthquake destroyed or damaged thousands of buildings. The most affected structures were made of concrete, which fully collapsed in some cases. They were lacking modern earthquake engineering. Houses that were built with traditional wooden methods fared better. Houses built on elevated areas suffered considerably less damage compared to those on lowlands. The United States Geological Survey, the USGS, reports that there was about 5 feet of subsidence along the Chilean coast in the affected area. The result was a number of buildings below water level at high tide. As much as 10 feet of uplift occurred in some places. Soil subsidence, the gradual settling or sudden sinking of the ground, also destroyed buildings, deepened local rivers, and created wetlands in places they previously did not exist. The river turned brown with sediment from landslides and was full of debris, such as houses. The lack of potable water became a serious problem. The earthquake also triggered landslides, mainly in the steep glacial valleys of the southern Andes. There were many consequences. For example, the San Pedro River was blocked. The water level of one lake started to rise quickly. The flow capacity of the river was not overpowered, but it could have been. This potential disaster would have violently flooded all of the settlements along the course of the river in less than 5 hours, with more dire consequences if the dam had suddenly broke. We need to think about our proximity to dams in these instances. Also, the earthquake destroyed Valdivia's flood barriers, and general land subsidence exposed new areas to flooding. To add more complexity to the disaster, 38 hours after the main Valdivia earthquake, the Cordon Col volcano erupted, believed to have been triggered by the earthquake. There are few eyewitnesses, and it received little attention by local media since they were busy with the severe widespread damage and losses caused by the earthquake. Significant amounts of lava flows and tephra were produced. The eruption ended 59 days later. Interestingly, an earthquake of similar magnitude occurred in what is now northern Chile around 1800 BC, as has been determined by dating charcoal and shells washed into the Atacama Desert by the tsunami. This is said to have been the largest known earthquake in human history, a magnitude 9.5 megaquake that caused a 5,000-mile-long or 8,000-kilometer tsunami that prompted hunter-gatherer human populations to abandon nearby coastlines for 1,000 years. The subsequent tsunami was so powerful it created waves as high as 66 feet, 20 meters, and traveled all the way to New Zealand, where car-sized boulders were deposited hundreds of miles inland. Evidence of marine sediments and animals that would have been living quietly in the sea before were thrown inland and found very high and a long way inland, so it could not have been a storm that put them there. Researchers use radiocarbon dating. The method involves measuring the quantities of carbon-14, a radioactive carbon isotope, found inside a material to determine its age. As carbon-14 is everywhere on Earth, deposits easily absorb it when they form. The half-life of carbon-14, or the time it takes for half of it to radioactively decay, is 5,730 years, making it ideal for scientists who want to peer back in the last 50,000 years of history by checking how much undecayed carbon-14 a material has. Another earthquake occurred in 1575, an 8.8 magnitude earthquake. It differed in the sense that it did not cause a tsunami in Japan. A similar earthquake will undoubtedly shake this area of Chile again. It's just a matter of time. The other question that we saw was, can an earthquake be larger than magnitude 10? No, earthquakes of magnitude 10 or larger cannot happen. The magnitude of an earthquake is related to the length of the fault on which it occurs. A fault is a fracture or a zone of fractures between two blocks of rock. Faults allow the blocks to move relative to each other. This movement may occur rapidly in the form of an earthquake, or it may occur slowly in the form of creep. The longer the fault, the larger the earthquake. No fault is long enough to generate a magnitude 10 earthquake that's known to exist, and if it did, it would extend around most of the planet. The next question we came across is, can you predict earthquakes? No. Neither the United States Geological Survey nor any other scientists have ever predicted a major earthquake. The USGS has stated that they do not know how, and we do not expect to know how, anytime in the foreseeable future to predict earthquakes. USGS scientists can only calculate the probability that a significant earthquake will occur, shown using hazard mapping in a specific area within a certain number of years. In summary, subduction zones are known to produce the strongest earthquakes on Earth, as their particular structure allows more stress to build up before energy is released. British Columbia and Washington State, for example, are also located on a subduction zone. We will link a video we made about these areas below for more information. We need to be as prepared as we can be and not be surprised if an earthquake occurs along a subduction zone. We'll also put some links to info about the 1960 earthquake in Chile below. If we can assist by covering a natural hazard topic that you're interested in, please let us know in the comments below. We are a channel that works with science, the scientific method, and empirical evidence. Science is an approach. There are no absolute truths in science. There are only approximate truths. If you like this video, hit the thumbs up button. For more videos like it, subscribe and hit that notification bell.